All right, let's go ahead and jump into the fifth and last question for this video, which is going to be a related rates question. So we are given this word file right here. I read it. It says an ice sculpture in the form of a sphere melts in such a way that it maintains its spherical shape. The volume of the sphere is decreasing at a constant rate of 2 pi cubic meters per hour. At what rate in square meters per hour is the surface area of the sphere decreasing at the moment when the radius is 5 meters? And then we're given the surface area equation for a sphere and also the volume equation for the sphere. Now, I know this may seem like a lot, definitely does pack a lot, but we just really need to make or take into account the numbers rather than being overwhelmed with everything that's saying. And just look for the keywords. For example, um, you can look at this sentence right here. It's very important. It tells us something very important. It tells us that the volume of the sphere is decreasing at a constant rate of 2 pi cubic meters per hour. Since it is a rate, that means that dV over dt equals 2 pi, negative 2 pi. Basically, all I did there is, since I know it's a rate, that means that it's the derivative of the volume, right? And it's being derived with respect to time. So it's going to be dV over dt equals negative 2 pi. Now, after this, we can go ahead and take in our second number, which is the radius, which is 5 meters. So we can say r equals 5. Now, we can go ahead and derive the volume equation, and we can say dV over dt equals 4 pi over 3 times the derivative of r cubed, which is, using regular power rule, 3r squared. But since it is a related rates question and we are deriving with respect to time, we also have to include the dr over dt. Alrighty. And remember that this 4 pi over 3 doesn't go away because they are constants that are being multiplied times our radius, which is, in this case, our variable. But if it were to be added, then they would go to 0 and they wouldn't exist. Okay, so from here, we can go ahead and plug in. So we know that dV over dt is negative 2 pi, and it is equal to 4 pi over 3 times 3 times 5, because we know radius is 5, squared times dr over dt. From here, we can go ahead and isolate our dr dt, since that is what we are solving for. We do that by multiplying our 4 pi over 3 times its reciprocal, which is 3 over 4 pi. And what we do on one side, we also do to the other. So I do 3 times 4 pi, that's 5 basically. So this is going to turn into negative 6 pi over 4 pi. Our pi's cancel out. We're left with negative 6 over 4, which is 3 over 2. Negative. Alrighty. So from here, we can say negative 3 over 2 is equal to 3 to the 5 squared dr dt. Now, we need to isolate our dr dt. So we evaluate this right here. So we know that 5 squared is going to be 25, and it's times 3. That's going to give us 75. And we're going to have negative 3 over 2 equals 75 dr dt. We divide by 75. What we do on one side, we do to the other as well. So divide by 75. Giving us, I'll go ahead and write this down here. I'll say negative 3 over 150, which essentially if you find the two common factors between these, it turns into -1 over 50 equals dr dt. Alrighty. So now that we found our dr dt, we can now actually solve for what the problem is asking us, which is uh, calculating the surface area uh, or the rate at which the surface area is decreasing. So the way we do that is by taking our surface area equation and deriving it. So we can say ds over dt is equal to 4 pi times the derivative of r squared is just going to be 2r times dr dt. From here, we can just plug in everything. We're going to have ds over dt equals 4 pi times 2 times 5 times -1 over 50. Alrighty. And from here, we can say ts over dt equals 4 pi times 10 times -1 over 5 over 50. And we can actually go ahead and multiply this 4 pi times our 10 and then times our fraction, which is going to give us, oh, sorry about that.